Welcome back yet again to the next exciting part of our journey through indices. Today we're going to do laws 3 and 4, and law 3 is talking about powers of 0, and law 4 is talking about when we have powers raised to other powers. So let's focus on the 0 index. This one's a really simple rule in essence once you've memorized it, but it actually is one that's really commonly forgotten. And this is the rule. Anything, it doesn't matter if it's a letter or a number, anything to the power of 0 always equals 1. There is an exception, and you'll never get one of these in the textbook. That's 0 to the power of 0. That's undefined by definition. But anything else to the power of 0 equals 1. Let's try some examples. 35 to the power of 0. Anything to the power of 0 equals 1. There's your answer. Let's try our second one. M to the power of 0. Anything to the power of 0 equals 1. Part C. 9a to the power of 0. Anything to the power of 0 equals 1, but this is a trick question. The A has a power of 0 above it, but does the 9 have a power of 0 above it? No, it doesn't. Realistically, that 9 has a power of 1 above it, but we just don't bother writing it. So this is really the same as 9 times A to the power of 0, and we know A to the power of 0 is equal to 1 because anything to the power of 0 equals 1, so it's really 9 times 1, and 9 times 1 is just 9. So you need to be careful. The 0 does affect the A, but in this case it doesn't affect the 9, so you end up with 9 times 1. Let's try this one here. Same questions, different example. Everything inside the brackets is raised to the power of 0, and anything to the power of 0 is 1, so the 9 and the A are affected by that power of 0, so the answer is 1. And there we have it. The difference between part C and D are the brackets. Let's go to part E. Everything in brackets. It doesn't matter how complicated or how messy it is, because it's all raised to the power of 0. The answer is 1. Part F. Let's have a look at the parts that have zeros above them. The only part with a 0 above it is that H. H to the power of 0. Anything to the power of 0 is equal to 1, so that now becomes 15 times 1 times k squared. 15 times 1 is 15. We get 15k squared. So let's look at this. Let's do the 4 times 9. 4 times 9 is 36. 2 times 6 is 12. So I get 36 over 12, but where did I get these G11s from? Well, G3 times G to the power of 8. When you're timesing, law 1 said when you're timesing with indices, you plus the powers. So 3 plus 8 is 11. On the bottom, I've got G to the power of 2 times G to the power of 9. When you're timesing, you plus the powers. 2 times 9 is 11. Let's have a look at this now. 12 goes into 36 3 times, and when you're dividing, you minus the powers. 11 divided by 11 minus 11, is 0. So that means you end up with 3g to the power of 0, because 36 over 12 cancels to 3. G to the power of 11 over G to the power of 11, you're dividing, so minus the powers. 11 take 11 equals 0. Anything to the power of 0 is 1, but that 0 doesn't affect the 3, so it just becomes 3. 3 times 1, which is 3. Okay, our fourth law says that when we raise a power to a power, we actually multiply the two powers together. Now when I get back next term, we'll go through all of these in a bit more detail again when we revise them, and you can ask questions, and I can actually show you why this is the case if you're still not sure why we're doing this. So let's try this example. We have 5 to the power of 6 but that's raised to the power of 10. So there's actually two powers in this question, or two indices. When you have two powers, you times them. 6 times 10 is 60. So the answer is 5 to the power of 60, and we're not doing that on the calculator because it's way too big a number. It'll go into scientific notation. So we just leave it as 5 to the power of 60. Part B, m to the power of 5 to the power of 11. We've got a power and a power. We've got two powers. When you have two powers, you times them. 5 times 11 is 55. Now you don't need to write this step here, these two questions. You can look at it and just go 5 times 11, 55, and write the answer down straight away. That's actually what I would like you to do. Let's have a look at part C. A to the power of 2 to the power of 4, and a to the power of 3 to the power of 7. 2 times 4 is 8. 3 times 7 is 21. So that becomes a to the power of 8 multiplied by a to the power of 21. That's dealing with the power to the power parts. Now when you're multiplying with indices, add the powers together. That's law 1. So when you're multiplying, as long as the bases are the same, plus the powers, 8 plus 21 is 29, so it becomes a to the power of 29. You will find with indices that you'll end up using lots of different laws in one question often. Let's have a look at part D. Well, I've got a power to a power here, this d to the power of 3 to the power of 5. So I'm going to times those using my power to a power law. 3 times 5 is 15, so I get d to the power of 15. And that's just all over d to the power of 8. Now I'm dealing with a fraction, because I wanted to get rid of the brackets first up here. Remember BODMAS says deal with the brackets first. Now, I've got a fraction. When you've got a fraction, that's dividing. So when you're dividing, got the same base of d, minus the powers. 15, take away 8 is 7. So d to the power of 7 is your answer. Well, that brings us to the end of that exciting journey. It's time for you to try some questions. Have a wonderful school holiday break, and I'll see you in a few weeks. Bye.